Hello, everyone. I hope I have set everything correctly. Hello, and welcome to the session. We're going to dive into building a multi-cloud data platform in a tightly regulated industry. My name is Natalie Godek. I'm a at Babylon. My background is in DevOps and systems engineering, and I'm really into my infrastructure work and building and designing systems. For the past 2.5 years, I've been building Babylon's data platforms, and I'm currently on the Data Platform Foundation's team, coincidentally. I'm also a photographer, and you can find me on Instagram and Twitter at UDesSuite. The Twitter tag will be on every slide, so if you want to tweet about my talk, don't hesitate. To set the context a little bit, let me introduce you to Babylon. Babylon is a digital healthcare company. We are on a mission to bring accessible and affordable health service into the hands of every person on Earth. That's quite a mission, so how do we approach it? Well, we decided to tap into a small and ubiquitous device that pretty much most people on the planet already have, a mobile phone. So we develop applications and services that allow people, our members, on one hand, to monitor their health and take care of their habits and understand their own body using Monitor and Digital Twin. We also allow them to see their doctor whenever they need from wherever they are using the phone as well. And we also develop AI-powered tools to enable our clinicians and our members to live their life better on one hand and do their jobs better on the other hand. As you can imagine, there's a lot of data in healthcare. And for a company that is doing AI-powered tooling, well, there is even more data. So now you will understand better why I'm here talking about this subject right now. So let's dive right in and set the scene for the challenges. Let's say that you have a product and you've developed some services for it. And your services are running on some sort of orchestration platform. They're exchanging events, they're exchanging data, and they need to do some sort of event exchange and event streaming. So you will have an event stream platform. Let's say that you chose Kafka. You don't have to, it's not the only solution. But let's say for the simplicity of things that you chose Kafka. Your product is growing, you're adding more services, your event streaming platform is also growing. And then maybe you're the next Pokemon Go or Clubhouse and you start getting popularity and your product is growing massively. And now all of a sudden you have your clients in Europe, in Middle East, in North America, all over the world in all different countries. And you have to deal with all of them and you have to serve every customer in every different country and also process all of their data. That's where Babylon finds itself today. We started in the UK and also in Rwanda. But today we also have clients in the United States, in Canada, and in Southeast Asia, in over 60 countries, I believe. And all of those members need our services and our products. And obviously, there is a huge streaming service underneath. So how do we deal with all of that? When you are becoming global, the scale of your challenge becomes huge. But also, how do you grow your platform correctly? Do you just dump everything in the same place and have the platform that you build from the very beginning just grow, scale horizontally or vertically, whatever you prefer? It's not exactly that simple. You see, your customer's data is personal data, and personal data is protected to a varying degree in every country. You have two main categories of personal data, PII and PHI. PII is personally identifiable information. PHI is protected health information. And dealing with those is really, really not that easy. You have four main challenges. First, you need to think about data privacy. People are becoming more and more aware of digital security in the digital world and how their data is being used and stored by different companies, used for profit and for research. And not everyone is cool with that. So data privacy really has to be in the core of everything that we do. If you want to have a competitive advantage, you need your systems to first guarantee data privacy and really be built in a way that empowers your user to feel comfortable with using your product. And also you will need to be very smart about publicizing the fact that your product is really thinking about data privacy so that your users know. There are multiple regulations and certifications that ensure that data privacy is being held up to. Some of the examples would be ISO 27001. That one is a standard that drives the way data can be processed. You have GDPR in Europe, which deals with sensitive information, like personally identifiable information, and tells you how to process that. You have CCPA in California, which is an equivalent of GDPR. And it really made loads of noise last year, about beginning of 2021, when it was introduced, because it was the first one of its kind in the United States, where processing of information is a little bit more free. So CCPA was the first standard that was kind of like breaking that freedom a little bit. And if you do deal with healthcare information and medical information, then HIPAA will be your best friend in the United States. You will need to comply with that standard as well. In terms of countries that you go into, you will need to think about data locality. Data locality means that data that you store and process has to be stored and processed in the country where it originated. So if your clients are in Canada, their data needs to be stored and processed in Canada, which means that you can't have the data stored in Canada and then processed on a pipeline server in the United States. No, it has to be processed in Canada as well. That's just an example, and not every country requires it. For example, United States require that their personal information, or perhaps it's only for health information, but basically it can only be accessed by employees that are on the US soil, which is quite a requirement. The safest thing to do is to assume the strictest data locality rules. Even if not every country requires it, it's easier for you to assume that everybody does. And lastly, if you do venture into the space of machine learning and artificial intelligence, you will be concerned with perception of AI in public. How AI products and AI applications are being used and introduced into our lives is a huge topic as well. And it's a topic on its own. And for the purpose of this presentation, we're going to stick to the technical aspects of these challenges and leave the perception of AI in public to the people who know how to deal with that best. If you want to take out one single advice out of the entire talk, is assume the strictest data governance laws. Assume that your data locality rules are the strictest. Assume that you have to restrict access to everything. Assume that everything is so strictly regulated that you just have to comply with everything. Often people see the regulations and the standards as an obstacle and say that, oh, I would wish that I could just develop my AI app and use all of the data available freely. But really, I see them as an advantage. If you have figured out how to do AI in Europe or even in Middle East, very often there is a blanket rule that all data has to stay within country, even operations data sometimes. And that's very challenging. But if you have figured out how to do it in those countries, then you have the entire world open to you. While the companies and like your competitors who only deal with countries where their regulations are not as strict, they would have to adapt and change their platforms. So this is my biggest advice today. Assume the strictest data governance laws. But this talk is also about multi-cloud, not only about regulations. I was once giving a talk in Switzerland, the land of mountains, cows, and expensive watches. And the biggest question that people had to me was, oh my God, are you storing health information in the cloud? It was as if they couldn't even imagine such a possibility. So is this possible? Like, how is this possible? In fact, it is. Like if you think about modern challenger banks like Monzo in the UK and N26 in Europe, they are building very resilient, very robust cloud native financial applications. How tricky is that? Financial industry is super regulated as well, but they are doing it. And COVID-19 has accelerated the transition into the digital world for many, many industries, including healthcare. So for us, our platform looks a little bit like this, very simplified, but for the representation of the state of the things. We have our apps and our event streaming on AWS. We use EKS, managed Kubernetes, and MSK, managed Kafka. Everything that is database and kind of live data is plugged into AWS as well for the sake of quicker interactions between services that run on EKS, lower latency. And our analytics platform is in Google Cloud. We use BigQuery and storage as our data lake, and we plug transformation pipelines using Cloud Composer, which is managed Airflow, and Cloud Functions for some more lightweight transformations. And then we plug in AI notebooks and Kubeflow and visualizations with Tableau and Looker, and have all of the analytics and ML, AI, applied sciences on that side of the things. But how did we come up with this selection of products? Why these particular services? Why these particular clouds? And how can you make better choices yourself when you are building your own platforms? Well, first you need to consider what your needs are. If your runtime is in a specific cloud or in a specific tool, where is your runtime? What's your preferred runtime? Where will your apps run? What do your teams know best? As we had our runtime already in AWS, it made sense to use MSK for streaming and plug all of the operational tools around that into MSK. But at the same time, what did our analysts want when they wanted a analytics data lake? Well, they wanted something SQL based. So BigQuery is SQL based. They wanted something that is really easy to learn. Google Cloud is pretty easy to learn and very easy to integrate between different services. So that made a lot of sense for us. We also had a lot of data engineers who are familiar with Airflow. So Google Cloud has a managed Airflow in Composer, and that made a lot of sense as well. Historically, we've been trying to be cloud agnostic, and many people say correctly that cloud agnostic is the most expensive way of doing cloud. So nowadays, where it makes sense, we choose to use serverless technologies and integrated managed technologies that allow us to bring the most business value as soon as possible. But all that considered, the regulations also come in place. And luckily, cloud providers have their customers' interest pretty high up there. They want to create the products. They want to do what you need them to do in order to extract the maximum amount of money from you, but it's also handy. So let's say for certifications and regulations, most products that you will find interesting to use in your platforms will already actually be certified for the biggest certifications and biggest regulations. So you can just check on their websites and Google out like whether, I don't know, is RDS, is AWS RDS HIPAA compliant? And you will see a page that describes all things on that front. So check the certifications of every product that you're going to use. I'm talking mostly cloud native products, but things like managed databases, managed services that are on the enterprise level that you buy subscription for, they will also have these certifications, and you can check with the vendor before signing the contract whether or not they can provide you with this documentation. In terms of security and like access, if you've been in the industry for 7-10 years, you will remember that the biggest concern against cloud was, will the cloud provider have access to the data? And well, our cloud providers, the biggest ones today, have done loads and loads of work to make sure that they don't have access to their customer data. They publish white papers on it, and it's very clearly said that there is data center security, multiple layers of it. Employees don't have access to data centers. Things are encrypted. Employees don't have access to your data that is in the data stores, except that one time when AWS added S3 get object role into their customer support role. That was a great day. But generally, they don't and they shouldn't have access to your data. And you also have certifications and like documentation extensively on that. That said, you should always enable encryption at rest and encryption in transit. Check the products that you use. Some have it by default, like Google Cloud. Some don't, like AWS. In AWS, you will have to enable encryption at rest and encryption in transit in most data-related products manually. That said, don't bother with your own keys, managing your own PKI, unless it's absolutely strictly required. In most cases, the cloud-managed keys are enough. The way they are stored and the way they are rotated and the way the encryption of the key itself is stored is usually sufficient for most regulations. And lastly, enable audit logging for data access and system events. Store those logs separately for a minimum of 90 days. And I mean separately in a separate bucket, in a separate account, and change the access patterns for those buckets, for those data stores where you store the access logs. Some audit logs log a little bit too much information. For example, BigQuery logs the entire SQL query, which means that if the analyst is querying specific things, there is a way to leak information, sensitive information in those queries. So make sure that you log down the audit logging stores as well. In terms of data locality, the architecture that I showed you with 2 different clouds for different purposes, well, as we operate in different countries, we have that platform in every location we have. And very luckily for us, both clouds that we use have regional presence in the countries we're interested in. That's also something that you need to check when you're using the product. Can it be deployed in the country where you're operating or where you're deploying to? Because that will allow you to ensure data locality is kept. That's all good. That's all cool. You have your regions, you've encrypted everything, you have your architecture. But the cloud services are still public APIs. Any resource in the cloud is a public API endpoint, which means it's on the internet, which means that it's not that great. So how do we protect the data that is in the cloud? There are a couple of things that I want to mention. First is that serverless products communicate over the internet. It's not immediately obvious, but if you have your databases, instances, and Kubernetes in your VPC in a subnet, in AWS, for example, then the communication with things like S3, Lambda, or logs will happen outside of the VPC and outside of your subnet. Any service that doesn't have an instance deployed into your subnet will be will be considered serverless. And so communication to it can exit the networks of AWS and go through the internet. And that is really not great. So how do we protect against that? Well, you can use VPC endpoints. For the services that do support it, when you deploy a VPC endpoint, it ensures that the communication between your private services and the serverless products stays within your subnet. This prevents sniffing of packets, man-in-the-middle attacks, and other joys of open internet and networks. It's the same for Google Cloud. Things that are deployed as instances into your VPC, like your compute, your Kubernetes, your Composer, will be within your subnets. However, storage, BigQuery, Cloud Functions, Cloud Run, everything that is serverless will be outside of your subnets. It's a serverless product. So when your instances will go and communicate with BigQuery, or your employees will want to query some data, that communication happens over the internet. So how do we protect against that in Google Cloud? We use VPC service controls. In VPC service controls, you create a perimeter in which you put certain APIs into your storage API, your BigQuery, your Cloud Run, and you list the projects that you want to protect. And the perimeter will act as a sort of firewall on steroids. You can say which identities, which devices, which IP addresses, subnets, and regions even can access those protected APIs. The ones that are not in the list will not be allowed. And other projects that are not in the list will also not be allowed to communicate with those in the list, in the perimeter. The way it works, the DNS resolution of those APIs changes when you put them in the perimeter. Instead of being bigquery.googleapis.com, it becomes restricted.googleapis.com. And all of the communication stays within Google Cloud Network, which is great. Then it stays within your project. The way you define who can access those APIs is through access levels, where you define the identities, networks, devices, and regions. Bridges, when you want to link two different projects into different perimeters. And the latest addition to this toolkit is ingress and egress policies, which allows you to say that, for example, all of the logging calls coming out of this perimeter, going to logging project B, will be allowed. This is useful when you're setting up centralized logging sinks, or if you want to set up data exchange with a partner organization. You can't bridge projects between two different organizations, so that allows you to set up like very defined rules where two projects in your orgs and two specific service accounts in your orgs will be able to exchange data between them. Now, how do we connect the two clouds that are now protected with VPC service controls and with endpoints and all of the security and all of the encryption that you've set up? If you think about it, if you think about two subnets, like two networks, two subnets, how do you connect to the two subnets? You will probably use a VPN tunnel. And that's exactly what you use in this case. Now, you will probably not have any subnets on either side if you only use serverless products, but to have a tunnel, a VPN tunnel, you will need subnets. So you set that up and you create a VPN gateway on either side. And those VPN gateways will have configurations that are connected. They will know about each other, they will exchange encryption keys, and they will exchange the BGP identifications. Then each gateway will publish a BGP routing table into its subnets that are connected to it so that the services know where to send packets. And there will be a cloud router on the Google Cloud side that will route all of the data into the subnet. Now, because the APIs on the Google side, once they are protected with VPC service controls, they change their DNS address. We need to tell AWS side where to find those APIs now. So we create A records in Route 53 for each of the APIs that we have protected. And we say that the API address, bigquery.googleapis.com, for example, points to a specific IP address that Google Cloud publishes. Currently, it's 199.36153.4/30. And once you've created that and the VPN gateway, the traffic that goes into BigQuery API will go through the IPsec tunnel. It will be encrypted and protected from the open internet. And once it reaches Google Cloud, once it reaches the VPN gateway on the Google side and goes into the local network, what happens is the traffic is now within the Google Cloud network, and the internal DNS resolvers in Google Cloud will know where to forward it to. This also means that if you have, like we said before, project 1, 2, 3 in a perimeter, well, you only need a subnet and the VPN gateway in one project within every perimeter. Because once the packets reach Google network, then they can reach their destinations fine. So you don't need a network and a VPN gateway and a tunnel in every project, just one per perimeter. So that's how it works. This is the most fun part of connecting to different cloud providers. And I'm sure you'll have some questions about it. Don't hesitate to ask in the Q&A section. I'll get back to them once I'm finished with this. We've set it up maybe 2.5 years ago, and it has worked perfectly fine for us. We were a bit concerned about the cost implications of sending data between cloud providers and using an IPsec tunnel. hasn't really been an issue. We checked at the beginning when we started sending data through it. The cost was really very marginal, not even comparable to the cost of actual data stores and data processing. So it's really not a concern. That's good news. And also, if you have concerns about the viability of IPsec tunnels and their scalability, that's also pretty well manageable. We haven't had any issues in 2.5 years. There has been a couple of times when AWS sent us emails about a degradation in the tunnel performance. When one of the tunnels, because it's a bidirectional tunnel, right? Then you have a pair of them. For every instance, for every deployment, you have a pair of them. And when one goes down, the traffic still goes through the first one. I think in 2.5 years, almost 3 years, we only had to restart a tunnel once, maybe twice. So it's really not an issue. And that's also good news. Yay. Now, a little bit about our future vision. So we have the streaming platform, we have the analytics platform, we have the ML, AI, applied sciences. Everything is working well. So what are our own plans? And I'm just really excited about them, so I want to share it with you. Firstly, we want to enable streaming data from any other source into Kafka. So we have our services publishing data into Kafka. Now we want to make that data that is living in BigQuery, in storage, in S3, in Sheets, anywhere, available in Kafka as well. There isn't a way right now. So this year we will be working on the infrastructure with Kafka Connect to enable like really a lot of data exchanges between different endpoints. And the other one is we would like to enable global research. And as I mentioned data locality before, this is really challenging. Like we can't just take data from the UK and the US and just process it in the same place. That's really illegal. We can't do that. So we'll be exploring different pathways and we're thinking maybe have federated jobs that run in every location and exchange the results, something like that. There's federated learning for that. We haven't explored that option at all yet. Maybe we'll look into that. Loads of possibilities, and it's also going to be very challenging in terms of how do you connect networks, how do you exchange that data, because all of the tunnels and encryption that we have currently is within the within region. How do we exchange that? So that's going to be challenging and interesting as well. That's all from me. If you are interested in those little future things that I just mentioned, we are hiring. So check out our careers page and reach out directly to me or apply from there. Thank you very much. Lovely to share this all information with you. I'm going to go into the questions section now. Hope you enjoy the rest of the conference. I've been joining the sessions before and will be joining the sessions after. So much information, so much inspiration. Really looking forward to all of the really cool talks before. What happens with sensitive data outside of foreign countries? How do you mean? We ensure that the data, sensitive data, stays within a country. So if it's about our do I have to press answer live? Answer live, yes. If we have to process data of our members in the States, the data stays in the States. If it's in the UK, the data stays in the UK. So everything happens in country. And yeah, again, thank you for joining the session. Hope you enjoyed, hope you learned new things. What sort of tooling have you looked at for federating jobs? So simply thinking about what we have already. So Airflow, we have Airflow deployments in different places, and also serverless. What if we could launch different Lambda jobs or cloud functions in region, and then they send their results into a central location? dbt as well for data pipelines. We have dbt used very extensively. Now it's the end of my broadcast. I'll answer your questions in the Q&A section, so check them out.